Welcome to everyone who could join us today for this webinar, Building the Case for a Digital and Collaborative Fibre Deployment. Before I get into it, brief history and background on myself. So as mentioned, my name is Paul Sulisz. I'm the Senior Vice President for the Americas at Biarri Networks. I'm also the head of the Global Customer Delivery Team. I've been with Biarri about 4.5 years, and I'm an electrical/electronics engineer by trade. Spent most of my career building or designing wireless and wireline networks, predominantly in Asia Pacific, and more recently, particularly my time with Biarri in the US and all over the world, as it so happens. So it's been a fascinating journey for us, and it's been it's a pleasure to present some of our findings, some of the key lessons learned to everyone joining us today. And for that matter, it's a good morning and afternoon, because I know there are some of my former colleagues from joining from Asia Pacific, which is a crazy time of day. So thank you. All right. So as I mentioned, I'm an engineer by trade, and I did university for 5 odd years, doing a double degree. And I think a lot of that background was helping mold engineers to learn how to think. Engineers, I think, really love to solve complex problems, and I'm of the firm belief that we didn't do all that training just so we drew lines on a page in a very rudimentary fashion. We still see a lot of network engineers and design being completed literally by hand drawing designs. There's absolutely a need and case for that when you're doing adds or drops to networks, but we're of the firm belief that really moving forward, there's got to be smarter ways to design and engineer networks as well as construct them. So as I said, we've had a very interesting, exciting journey over the last 4 years. And over the last few in particular, we've seen an unprecedented shift towards data-driven and digital approaches to fiber deployments, not only in North America, but globally. I moved out here just under a year ago, and I did that really because the need in this in North America, and in particular the US, is quite phenomenal. It's an exciting opportunity for a team approach, and that's something else that you'll hear a few times through our webinar today, is just how important a team approach is to solving these sort of problems. And look, many organizations have reached that point where their existing or legacy systems and processes have inherent inefficiencies and are now too big to ignore. Almost all deployments these days are multi-party, delivered by teams. So their ability to collaborate and be referencing the same single source of truth is more important than ever. Our objective with this webinar and this case study actually is to discuss the lessons learned over the past few years and illustrate how some of these lessons have been implemented through a number of projects, not only here but abroad. So we sense that there is a shift in the market out there, and more organizations are willing to participate in these types of deployments. So we really hope that we provide some useful tools and techniques that we believe, again, are very helpful in your deployments moving forward. So since mathematics is at the core of Biarri, and as a group of companies, we try to commercialize and make mathematics really domesticated and accessible by all. So in networks in particular, we focus on solving problems in optimizing and automating fiber-fed networks. So from that perspective, it's worth just pointing out some of these key concepts of big data, artificial intelligence, machine learning, since many organizations focus on varying elements of what you see in front, these quadrants. But at Biarri, we really focus on 2 elements of these, one being the analyze portion on the top left, where we focus on how we can utilize descriptive analytics to display, explore data that we see, and predominantly that's geospatial data. And on the bottom right there, at the core of our capability and is really the focus on optimizing the network, the physical infrastructure. So that really aids in deciding, planning, scheduling, and that's essentially called prescriptive analytics. So these are the ones that we focus on. We don't really do too much in terms of game theory or in predictive analytics. We leave that to others. So we've been saying for years now that the tech is here, technology is available to all, the tools and techniques to go from planning through to construction have matured. And this is really to a point where it should be accessible to most organizations. Although many can still consider taking a fully digital approach, that is removing paper from their deployment, this is typically, we find, a huge leap of faith. And more companies, however, are starting to take on that leap. They're willing to take that leap. And that varies from cooperatives, municipalities, utilities, engineering companies, and service providers or carriers. So when I first joined in Biarri 4 years ago, this was very new. We were still exploring what that all meant to us as well. And it was considered a huge leap of faith. In the last, I will say, 12 months, this is more of a big step by a lot of organizations, and we're seeing a huge shift in the market towards this kind of approach. People are seeing the benefits, and they really want to get those downstream efficiencies when it comes to construction and moving forward into operations. The speed to market, the speed to connectivity is greatly increased by taking on such approach. So it's rare that a single entity can do the whole thing. Many purport they can, but unfortunately, time and time again, we see that those that signed up to that dream are often disappointed. And it's really disappointing for us as well, because the problems that we're trying to solve are too huge for just us. It's, as I keep saying, this is a team sport. It requires a lot of us to get together and try to solve these problems. So there is a lot of disappointment out there, and it's a shame, and we get called in time and time again to actually try to help and remedy some of these rollouts rather, and these deployments. So technology alone is a great enabler, and it's free for smart people to do things they need to do. More and more people are automating by using scripts, and we hear quite regularly now engineers that have been grew up with CAD, so to speak, are starting to automate and use scripts in their day-to-day working lives, which is great to hear. And the key here is to really step away from some of those huge spreadsheets and the approaches we used to take. The amount of times I've personally had to pivot huge spreadsheets of data to try to figure out exactly what the data is telling me is nuts, and it's something we need to be conscious of as we move forward. So as we've said, the tech is here. Many people are starting to automate where possible, and this is giving them a great leg up. Creating interoperable data models that are accessible across the entire value chain can exponentially improve efficiency, particularly when coupled with automation and optimization. These data models allow transparent, accessible flows to all parties, so collaboration becomes a breeze. And this is something we believe very strongly has been an enabler over the last couple of years in particular in this market, where making that data accessible by having these interoperable schemas that allow transparency to all parties has been quite fascinating to watch and see how everyone takes that up. So in order for this tech to work, we need to implement rich rule sets that are objective as possible. This helps the tech drive designs closer and closer to being constructible. To add a further turbo boost to this, the sooner in the value chain that these strict data and rule standards are employed, the more accurate the design will be. And really, this can really aid in everything from make-ready engineering and permitting. If we understand exactly what needs to happen in those stages of the project, the sooner up the value chain, the more you can implement the automation to aid and get you there closer. So when it comes to getting out in the field and doing PLAs, for example, then you have a greater level of certainty that the poles that will be assessed and analyzed with those that can be actually used. So you're not wasting as much resource in the field when it comes to validating the constructability of the network. Embracing change, trusting the math. And this is something that we've seen, again, over the last 6 to 9 months in particular. More and more people and engineers are starting to trust the fact that the math can do the work a lot quicker than they can. And it's a credit to those that are working in innovative organizations taking up this step change in approaches. So as will be evident in the case study we're about to explore, creating the means for all parties to be working off the same single source of truth is critical to maximize the benefits of a digital approach. Although some automated techniques are hard to understand, I certainly don't attempt to understand all the maths completely. It is, however, important to gain its trust. Some of the most effective ways to do this really include standing up proof of concepts, running small pilot projects that show how the traditional approach is mapped mathematically, and then run this and compare this to these proof of concept results. And we've seen time and time again where the proof is in the pudding. You can see the results for yourself, and it's easier for organizations to take that leap, or step rather, moving forward. Our experience also suggests that keeping things as simple as possible, transparent and accessible, just makes life so much easier. I'm of the firm belief that this is the approach, one of the key reasons actually, that we get engaged in earnest around not only the US but globally. So looking at this diagram here, we can see that at the core of all this is really creating the ability to focus in and create one set of standards and schemas that are interoperable from end-to-end value chain. And this means that we really need to understand the geospatial data that can be used and will be used, and how the fidelity of that can be improved throughout the project. We need to establish architectural constraints, construction constraints, which are sometimes forgotten in the planning phases of projects, and in-field feedback. You know, how is that incorporated into a design, and when? So from this perspective, it all starts with leadership and having the right organizations that buy into the approach, that say, yes, we want to have this transferable and accessible approach from us all the way through to the construction teams, the design teams. So in terms of the value chain, you know, everyone should be really singing off the same hymn sheet, which is, you know, really the leadership team, planners, designers, whether that's in-house or in a separate organization, field data validation teams, which again could be outsourced, write-outs, so not only the initial data sets to identify confirmed demand, but also checking the constructability of a design in the field, and then your engineering and or potentially construction vendors. So in terms of the case study we're going to run through, this is really related to our experience with Craighead Electric. And this is a project we undertook with Irby, who were the main innovators of the approach in terms of bringing our capabilities and others to bear. So we've partnered with Irby on this project as well as others now. So here is a quote from the head of engineering from Craighead, Jeremiah Sloan, who was kind enough to share this feedback on how this digital approach has impacted their plans to build and operate their fiber network. So what's really fascinating is, you know, we really all have, you know, rules of thumb and gut feels on what we think some of these deployments should take. And, you know, that is obviously biased in many ways from our experiences, our understanding and experience of and local expertise. So what was really, you know, a great result here is that the build of this project being a very rural one, where initially it was thought it was going to be hard to get construction resources, the right amount of resources to keep up run rates, we see that this build is going to come in way in on time. So it's been a great result for everyone involved so far. Okay, so here is the first of a few checklists that we've prepared, and we really hope that these can be used time and time again by yourselves out there when it comes to, you know, trying to implement these types of approaches. So before we deep dive into the details of the case study, let's kick off with this one. So first things first, one, make sure you have all parties represented as soon as possible in the project. The more of the players you can have in these early kickoff meetings, the better. And this really should be even before contracting stage where possible. It's often hardest to have construction represented, we get that. So if you can have the closest thing to that, which is those that are looking after the construction management, at least then they can advocate for how the construction will be performed. We find that trying to get, you know, making decisions by committee is pretty tough. So typically we find going into these initial meetings, advocating an approach that has been proven or is almost there is a great way to start. The other key here is to have the subject matter experts for each area or function, particularly if some of these are not in your wheelhouse. Having them in the meeting is really critical as well. And look, we have that time and time again. We don't purport to know everything. There's many elements of a rollout that are, really not in our wheelhouse. So we bring others in to build out that team capability. 2, ensure that your workflow between all parties is agreed, transparent, and accessible. And the focus there is on those 3 key words at the end there. It's agreed, transparent, and accessible. Getting many parties to agree by committee, as I said, is really tough. So going in there and advocating is something I want to emphasize. And it really helps in getting buy-in from all parties, particularly since we are saying that there's going to be a team around this approach. 3, ensure that your data flows between all parties are agreed, transparent, and accessible. Having a single source of record, a repository, if you will, for the project data and the associated information is the best case scenario. I've never seen a silver bullet program that does everything. However, we've seen that there are a number of variants of combinations that really work and work well, and they are accessible. They're relatively inexpensive to implement and really can be catered for well and truly by those looking at project budgets and particularly overheads to run these projects. So again, being accessible also means that it is not costly to set up. So it is important to think about, okay, is this really going to break the bank in terms of these systems to manage this end-to-end process? 4, ensure your communications plan is fit for purpose with the right cadences. Now, like any plan, it's a plan, and it should be altered to suit the needs of the project. In terms of the cadence, we see that it really depends on what stage of the project you're in, and also the types and the amount of change that you're looking to undergo as a team at the table, as well as how that interacts with existing networks, existing players, and things like that. So having a comms plan that allows the cadence to be shifted and changed is quite important. One of the greatest benefits of implementing a digital approach is that it can drastically reduce or even eliminate, in some cases, reporting for reporting's sake. And I know I used to be a victim of this when I was constructing networks a few years back now. One of the hardest things was, getting all the information in. And what I found was, personally, I was spending roughly, on average, a day a week just on reporting. And all I did is collate data, pivot that data, make really nice, charts, graphs to then, help manage up, down, across, not only my organization at that time, but others. So that's a huge time commitment just for reporting's sake. So having these live dashboards that are now, again, accessible through this type of approach allows all stakeholders to have the ability to sign in, see what they want to see, customize the views. If they really want to report, they can do their own exports to the customized data sets that they wish, and they can go from there. So this really leads into 5. Create a single source of truth for all your project documentation that is transparent and accessible by all stakeholders. We often see systems that are really okay and are implemented for the general contractor and or the project management teams, but are not linked all the way through to construction. And sometimes we see construction companies that have their own systems because there's no other way for them to track exactly what they've been doing. So the intent here is to really implement a system that is interoperable at end-to-end on the value chain, being completely transparent in terms of the monitoring and controlling the work that is being done. So again, there are systems out there that used in combination can achieve this. So just going through these again, just to highlight them, make sure you have all parties represented. Ensure that your workflow between all parties is agreed, transparent, and accessible. Ensure your data flows between all parties is agreed, transparent, and accessible. And the other thing to point out here also is that having these set up at the beginning really helps you control scope. It really makes it very clear for all parties where the delineation points are in terms of your rollout. So with we've found that implementing points 2 and 3 here really help us communicate the approach, communicate it with all parties, and everyone knows exactly who's doing what. So again, comms becomes very simple. Ensure your comms plan is fit for purpose and has the right cadences. Again, think about how your live dashboards can be used instead of generating reports, and create a single source of truth for all your project documentation that is transparent and accessible to all stakeholders. Okay, so getting into the case study in a bit more detail. So Craighead Electric Cooperative Corporation is in Arkansas, covers approximately 25,000 homes. Their initial CapEx investment was approximately 63 million. They initially, as I said before, were thinking that the deployment would take about 5 years, but that is potentially going to be cut in half. Their ISP, which is called Empower, this is a clip taken from their website, and you can see the phasing of the project, and that's essentially been fed again from that source of truth that has been linked all the way from the planning through to construction. So it's important to note that these charts that you see that they're utilizing is not something that was hand drawn. It was fed from the data sets that work using that interoperable schema, and it's been employed from the very beginning of the planning phase to now what is well and truly into construction of the network. Okay, so let's see who was involved in this project. As you can see from this diagram, up until now at least, there have been at least 6 parties involved. Irby, as I said, have been the prime. They're the organization that brought us in, Biarri Networks. So they're the overall lead for this. And I've got to say kudos to Irby, who are not only equipment supplier in that electrical space, but they've taken on this innovative approach that they're taking to the market. It's been, they've been phenomenal to in terms of enabling this to Craighead. Looking further, we brought in Render Networks, who provides specialist applications for fielding and digital construction management, including as-built capture. For those that haven't seen some of the capability of Render, we believe they're going to be at Fiber Connect. It's worth checking their systems and applications out. Render is one of those organizations we've partnered with time and time again. In terms of their capability, it is something that is completely complementary to the way we see the world, is complementary to the way we try to deploy these digital types of approaches to network design, engineering, and construction. DH Construction was used as the construction partner, or is used rather, as the construction partner for this network. And again, they've been utilizing these systems, this paperless approach, which was really something, as I said, was employed from the beginning. And it was great for us to be involved in that. And it's been, so far, it's been a phenomenal project. And again, we will also be at Fiber Connect, and I'll touch on this at the end, but more than happy to answer any questions from those that are going to be attending. Okay, so looking at the timeline here, we kicked off the project roughly in February 2018. And that's again, the focus here was to have the right people in the room. The focus was to have, and that means all the key stakeholders across that value chain, as many as possible, and really set those schemas, set the standards, set the approach right from the get-go. Within the month, we had a high-level design ready for the entire footprint service area of, again, roughly 25 to 27,000 homes. And that was, that's really useful. We've found for organizations where they need to confirm that the CapEx they have or they're going for is going to be adequate for their rollout needs. And we had the first customers lit in November. So obviously, a few months after that HLD, the design was validated in the field, and then construction commenced thereafter. So over the years working across the globe, one of the challenges we faced was working with different nomenclatures, network architectures, and data schemas. We found that there's really no main or universal standard anywhere. Yes, many of the elements or attributes across these standards were similar, but everyone had, created their own unique spin on these, whether it be a part of that schema or standard. So we started working on creating a set of standards that we could share with those we engage with, whether they were customers or not, and found that these greatly assisted us in not only communicating what was going to be achieved, but also how. So these schemas have really become our compass, and they guide discussions from early inception of projects through to implementing data models, from planning through to construction. So one of these standard documents we call the Complete Architecture Playbook, or CAP for short. It's really become the ready reckoner for the architecture of the network, and really capturing a lot of those key elements that ultimately are used to configure as much of the automation and optimization as we can. So this is one of the first documents we reference and complete with the project team. Our preference also is to really do this in person. So the photo you see here is actually one of these establishment workshops that was held for such a project. As you can see, there's many people in the room, and there's at least 4 organizations represented across the table there. Not only have we worked very hard to try to come up with this architecture playbook that we leave with customers, and it really becomes sometimes their first record, right? As you know, there's, considering the level of documentation out there, it really depends on the size of the organization as to how much of that is actually documented. And the larger the organization, typically they do have standards, requirements, design and construction guidelines that are documented. As we know, as you move to smaller organizations, that becomes tougher, and it's harder to find those things written down. It's typically in the heads of a few people. So these, not only does the CAP serve as a way to guide that discussion and document those, we also have come up with these schemas or standards around the input information, how we output, what the output looks like in terms of a geospatial network that is fully connected, in terms of how splicing is represented, and also, how and what gets captured in a walkout, a field validation, whether that be demand or the actual design validation itself. So we believe it's critical to create an evolving digital design for feasibility, high-level design and low-level design. By creating and iterating on the one design from feasibility through to low level, you gain a far greater control over improving the fidelity of that design. You're not wasting, these wasteful steps where designs are, potentially thrown across the wall into another department. Then maybe that design is taken on and recreated, or there's a lower level or a high level design completed or created in another system, and then moved downstream. So when we're trying here to really eliminate kicking the can down the road, if you will. So this approach where that feasibility or initial design was used as the start and then iterated on for what became the high-level design that was taken to field validation, and then ultimately the low-level design has yielded some really great results. And what we found was that in this particular case at Craighead, we found that end-to-end, as we progressed and as checked against the initial assumptions of what was required, we found that there was a saving of approximately 400 miles less in terms of distribution. We could realize at least a 10% capex saving, which meant Craighead could really determine what to do with that saving. Is that something they could implement somewhere else in their business plans? Could they serve a broader footprint with that cost saving, and so on? The other key here is implementing a means by which feedback can be incorporated into the design process and engineering process as tightly as possible. So agile feedback and holistic rule iterations. What this means is that as we learned from field validation and other and building and increasing the fidelity of the design, those rule changes and minor adjustments could be incorporated into the way the design was, or future designs rather, were created. So those lessons learned were incorporated to improve the overall result. So if there's systematic issues that are found in the initial stages of the design of a part of the area, you can implement the remedy to those, and then ensure that the low-level designs of the designs thereafter have incorporated that change or remedy. So you're not having to do the rework time and time again for the entire footprint. So having those systems in place all the way from the beginning, and obviously includes, how change is implemented, what does continuous improvement look like, have yielded additional cost savings. And again, this comes back to additional savings through strategic collaboration on planning. Again, to iterate right at the beginning. So this brings us to augment and digitize data collection and parsing. So getting accurate and reliable data sets of all existing assets and adjacent services is a universal challenge, irrespective of where you are in the world. We don't think we've seen anywhere where the data is perfect. It is a huge variety of data sets that are very close, all the way through to data sets that don't exist. We see in developing countries that there is very little geospatial data that can be used as layers. And a lot of organizations think because there is aerial or satellite photography that is geospatial data, which is clearly not. So there are some interesting challenges globally that we face time and time again. Yes, most deployments should show should be moving to a point where most current geospatial data is pretty good. And those days where we signed our life away in these contracts where, hey, look, we're going to give you these data sets, but you really shouldn't trust them. You need to go out and check for yourself before you commit. Well, hopefully those days are gone. I mean, I remember 10, 12 years ago where that was absolutely the case almost every time, because the DBORs, or the databases of records, had data that was typically obsolete. And there was so many issues with as-built incorporation that these service providers that were trying to deploy these networks, could not commit to saying that data was accurate enough that the next design or the next evolution of that network was really, underpinned by really good data. So by implementing a data-driven digital approach, it means for those layers of information that you do not have the most accurate and reliable data, then you collect it and you incorporate it. And you incorporate it as soon as you can in the design process. Furthermore, if this is done in accordance with schemas that we've talked about and these standards that are interoperable, incorporating the data or change in the design becomes far simpler a task and can be turned around very quickly, and in many cases automatically. These tools that are used in the field, when used correctly and associated with high fidelity location data, will aid that final asset being not only built right, but also maintained with a solid GIS data set. And that's got to be the golden ticket, right? That's got to be the nirvana that we all have to shoot for. So it's important that these systems used are set up right, configured in such a way that the resulting output of these field validation work and other similar works is ingested automatically. Once you introduce elements such as free text input into some of these apps in the field, then someone will need to interpret that information and try to make sense of it. For instance, let's say that someone's put a comment, this size vault will not fit here. I mean, that is extremely ambiguous. It doesn't really aid in decision-making process for anyone. Is that because the vault size is the problem? A smaller vault would actually fit, so maybe we need to think about redesigning the types of fiber going in there? Or is it that no vault will fit there because there is an obstruction? For instance, there's something that wasn't in the geospatial data that's found in the field. It could be a latent site condition. So really the alternative approach is that you need to implement tools that give the person doing the validating the ability to choose what they see, and then build logic to help either that person on site or those back in office make the final call on what has to change. So build a collaborative and transparent construction management approach. This is the other area that can be really an absolute differentiator in your deployment. Utilizing a digital construction management approach is huge, and we see this really coming through time and time again now. More and more organizations are buying into this approach, and it really should focus on converting or mapping the design into actionable work. And having that work sequenced and tracked, that work is really, when I say sequenced, it's optimized in terms of the sequence, and it's got to be done in such a way that it's near impossible to have any downtime, right? Because we know that remobilization is an absolute killer when it comes to construction, and it's one of those things. And having run construction crews, it was something that was one of the biggest red flags. Was, hang on, I've got a crew sitting out there now waiting. And then you've got to pay downtime, or somehow you've got to absorb that cost. So it's terribly inefficient. And so what we're saying here is, with a digital construction approach, these sort of things really should be eliminated. In the Craighead case study, this meant that it really has taken 4 people to manage the entire construction of the network. So far, there's been 0 delays. And again, all information has been accessible, and this has really aided in how materials are issued and managed, inventory management itself, what is being constructed on a daily basis, how is that reconciled against the forecast, and really, because it is all interlinked via these interoperable schemas, it means that there is really no confusion, no argument as to what was being completed in the field by that crew to what is being invoiced. There is a intrinsic link. So that whole process is, dramatically sped up. And what that means is there's more certainty for construction crews and construction companies to get paid for the work they've done. And we've seen this as a massive benefit. So as we push forward into current projects, as you're trying to think about that and how you do that, it's important to understand exactly what it is about this time around that will be different, because it needs to be. What needs to be better, because it needs to be. There are many areas for organizations to differentiate, and there is no one size fits all. We know that. Most of us know that. So, making the progressive steps in the right direction is important. Here's a nice, it's a kind quote provided by Patrick Reams, the Director of Technology Communications from Irby, just calling out the fact that, like a lot of organizations out there, we try to take on a different leading approach that has really aided this rollout. Okay, so getting back to some of the Craighead stats, digitize and control all network construction requirements. So a digital design and construction approach should automatically yield a bill of materials, creating the associated labor with that materials, again, should be automated. So, that's something that, again, the technology is here. There's organizations that can help you achieve that. We still meet people and customers that say, hey, this is going to save me, a week of translating this and using a huge spreadsheet to convert this design into a bill of quantities that I can let for construction. In the case of Craighead, this approach has helped minimize equipment wastage. We're currently sitting sub 2%, which is quite phenomenal. This digitized approach also, with the appropriate data flows across the construction of the project, means that the construction management overhead is drastically reduced, which again is a massive positive for the project. These transparent data flows also have meant that stakeholders have the visibility they need into progress reporting on a daily basis. There's no need to wait for reports to come back or attempt to reconcile what was constructed from drawings and as-built submitted, weeks, months later. This is done near real time. So this has really revolutionized how quickly they can go from as-built capture, invoiced, completely billed, and so forth. Ensure a transparent and digital as-built asset is created. So there's a few key words here: transparent, and this is something we've been emphasizing all along during this webinar. A field to office connected approach means the data link is there. It is important to make that transparent to the right people. And really that should be almost everyone in that value chain. And really the system needs to be enabled to do that. It needs to be implemented to be able to provide that transparency and connection to all people, and all the way through to tracking the as-built network at the end there. So where you have the option, implementing systems that allow you to track the network inventory as it comes on stream, that's something that's critical. So the best systems will allow you to track the asset information as it is installed. Something I forgot to mention was that when it comes to that connectivity, Vitro fiber map have been used there. So as render system is being utilized for the construction, that information is being passed through automatically, and then the as-built record is then automatically integrated into the Vitro fiber map system when it comes to the Craighead example. And again, Vitro fiber map and renderer will be at Fiber Connect, so I strongly urge everyone to go and see those guys and see what they're capable of. Again, we can't do everything. We don't want to do everything. We focus on our elements, but it's important to note that it's to work with others that can fill the gaps in capability and provide that amazing, unique experience for customers. So this transparent approach will also allow for rapid remediation of your plans. So let's say that something occurred during a construction task, and then you've got to think about what are the following tasks that are coming. Are those tasks blocked? When can they be enabled again to be let out? So again, we don't have downtime. So this is really, again, one of the key important differentiators of a digital approach when it comes to construction management. So now let's look at our final checklist for today. This one's really focused on standardization. Okay, number one, create standardized interoperable schemas for all of your end-to-end processes. So again, this has to be multi-party across the end-to-end value chain. And we're not talking about compatible schemas between, let's say, planning and design or design and construction. This is one set of schemas and rules that can work across the entire value chain. So again, ensure your schemas are transparent and accessible. This means that it's relatively easy for organizations to reference that information and utilize it for their benefit. So it's important not to create blockers by having really challenging transforms required to map varying schemas. Create a single repository of data for your end-to-end process and associated documentation. Again, there's no silver bullets here, but there are many systems that work very well together. Many of them are lightweight, really, and it's amazing what you can get out of using some of these that are essentially software as a service-based systems and applications out there. Understand that all physical assets need to be inspected and or built, and these need to be mapped geospatially and version controlled. Again, this is critical when it comes to helping enable and improving fidelity of information, not only the design, but also the as-built at the end of that value chain. Make your design accessible from the field, digitally with the appropriate business processes. And this really, again, talks to building that fidelity, improving the fidelity of that design. So whether it's the application on the tablet or the iPad in the field, whereby a decision on what was constructed can be made directly by that person, whether there's a business process that you build to ensure that as them changing or shifting the asset or changing the quantity of what's been constructed is then flagged or triggered to someone in the office or a supervisor for them to approve. Those sort of systems and processes need to be established. And again, we found that when that is done, the results are far superior and you have a very good view of what's happening in the field. Again, waiting for drawings to come back at the end of the week, including and photos that you need to search for, is something that becomes a huge headache. And I remember when back in the days when digital cameras were relatively new, I used to have my crews have to come back 2 hours early from site just so they could download all their photos, rename those photos, and collate all their as-built records. It was nuts. And we had to leave site so early, and there was still work to be done. Whereas now, with this kind of technology and applications and systems that we're talking about, the guys in the field can stay till the job is done, can stay till the appropriate time to finish the day's work and catch the photos required. They are automatically geo-labeled and attached to the assets that are built. So it's a dramatic improvement on how things used to be done. And again, this really helps everyone in the value chain, and in particular the guys constructing. As someone that used to run a construction company, it was critical we got paid. So we didn't, in those days we had to wait and wait for that last 10, 20%. With this sort of technology, I would have loved to have this in my hands back then, because it would have meant that we would have been paid sooner. There's no issue of identifying exactly what was built. versus the forecasted, record for construction. That reconciliation between the for-construct network and the as-built network happens on a daily basis, near real time, if you will. So just in closing, as I've mentioned a few times, we will be at Fibre Connect, and by all means, please come by and say hi. We hope that the these checklists that we've provided today and some of these insights have proved invaluable. We certainly will be doing some follow-up webinars, hopefully, and including some of these partners on those, and hopefully having some panel conversations where people like yourselves and others can inquire and query all the players in this value chain that have so far made Craighead Electric such a success. Because again, it's this is a team sport, and it's we believe it's critical that the people that are involved are working closely together using these transparent systems, accessible systems to really help drive a faster approach, getting to that constructed network a lot sooner, improving time to revenue, and ultimately lighting customers to connect the world. So with that, I thank you. Thanks for listening, and I'm hoping I've got some great questions from you all that I can answer. So thank you once again.
And, thank you, Paul, for your great presentation. Let's give it another minute or so to see if we get any additional questions submitted. Right now, I have 2. So let's go with number 1. What if a customer already has a database system they are using for their existing network? Is it possible to incorporate this type of digital approach in that case?
Yeah, thanks, Doug. That's a really good question. It's something that we see time and time again. It's rare that you have the opportunity to with a customer where they don't have a database of record currently. A lot of, most utility companies have existing records, particularly of their electrical plant, and that's, typically geospatially. So, there's often the question of, okay, can the telecommunication infrastructure be incorporated into that database, or is it better for us to run a separate database of record and system to help us with connectivity and with BSS and OSS. So look, it's generally speaking, we found these types of approaches are flexible. Really, the approach should be agnostic, and it should work with either case, where there is an existing system or there needs to be a new system implemented. In the case of Craighead, they made the conscious decision to stand up a new database of record. So Vitro FibreMap have been involved in that in this instance. And again, I urge everyone to talk to Vitro and get them to explain and advocate on how that's gone for them. So yeah, it absolutely is the short answer. It's never too late to start. It's never too late to also change the approach, considering a digital approach can be implemented relatively quickly because it's not reliant on having a huge amount of resources across the end-to-end value chain.
Great. Thanks, Paul. Next question. What does this mean for 5G cellular and small cell deployments?
Yeah, that's a great question. What we've found, in particular, I'll say over the last 9 months, is we've had a lot more conversations and been involved in a number of projects now that are based on small cell type architectures. Whether it be the fiber being front haul, back haul, a combination. A lot of organizations are now looking at the amount of fiber that needs to go out there, not only for small cell but obviously for 5G. So in those cases, the configuration and the architecture is obviously different to, let's say, a fiber to the home deployment, but in essence, it's an optimization problem from trying to solve ways to help connect 5G, small cells, and those these upcoming technologies. So it's in terms of the digital approach, it can absolutely be implemented. Obviously some of the standards and schemas are different because they need to allow for the wireless connectivity in these networks. The parameters that that organizations are looking to optimize out there change. Whether they're building for a carrier that's doing 5G, whether they're looking to build their own dark fiber network to help serve and monetize when it comes to providing ultimately connections to these 5G points. All that needs to be incorporated. So we've seen a drastic increase in these organizations working with in the small cell and 5G space, implementing these types of digital approaches. And again, a lot of it is because these organizations are typically, one, completely under-resourced as they are. Two, they find that the traditional approaches are too slow. Some of these organizations have said to us, look, I've got 40 designers, but I'm going to get 40 different designs because engineers are engineers, and being one, we like to have our own spin on standards. So having these sort of approaches where it's far more objective is critical to ultimately building the one type of network, right? Because maintenance becomes far easier. So whether they're understaffed, it takes too long. Having their organizations learn a new variant of a technology takes time. Building these into a approach that is far more objective and can be scaled very quickly is a huge bonus. So coming back to the initial question, and sorry for going on a bit, but it's absolutely this type of approach can be implemented, and we're having a lot of these conversations with varying customers, and I'm sure we're not the only ones, and that's great because again the problem is huge. 5G is going to be massive. There's a lot of small cell activity already. The amount of fiber that's going to go in the ground is going to be unprecedented. So optimizing and trying to reduce that fiber footprint as much as possible is critical, I think, for everyone. So yeah, absolutely. I think the impetus is on all of us to think deeper about that problem and, try to, build once, design it for longevity, and then build it from there.
Right, now we got a few more, Paul. Next one, you mentioned over 700,000 less in construction costs and requiring 400 miles less distribution fiber in the network. What was the benchmark network design that suggests these large savings?
Yeah, that's a great question. So the initial benchmark feasibility design was created using traditional, per home pass types of metrics for that type of density of deployment. So it was essentially we think it's going to be approximately this many thousands of dollars per home passed for our type of for our network in this area, and also looking at our existing electrical plant, which is again what a lot of cooperatives and utility companies do, is they look at their electrical route miles and say, well, we have roughly this many miles of plant, so worst case, we're looking at about this much if we were to reuse all that plant. So that's where the initial numbers came from. Utilizing an optimized approach to, again, whereby we're looking to minimize the amount of network to serve all the demand. That's how the next, that first optimized design yielded those sort of results. From that initial benchmark that was created, again using huge spreadsheets and these sort of factors and a lot of averages, law of averages, through to using an optimized model that actually designs and connects a physical network. That's where those numbers came from.
Right. And we have one more. Sometimes design resources are limited and a daily agile approach may not be feasible. How else can you maximize design team optimization and efficiency?
That's a really good question. I think, yeah, we've seen a few different approaches that work. One is, having the ability to utilize as much, information that can be manipulated objectively as possible is key. Having design teams that utilize the same sets of systems that minimize subjectivity also really helps. We see everything from the planning stages that take months, that move into design that can take months and beyond. And there's even from my day, that was the traditional grenade over the fence. So if an agile approach cannot be implemented, I think you got to look for what's the next best thing. What is a natural cadence that will work for my team, and what's a good, so measuring the current cadence of what the turnaround is good, because you need to understand what your baseline timing and cadence of turnaround is, and then finding ways to really bring that down, or speed up rather, right? So how do I speed up my cadence of my delivery? And you're not always going to get 1 or 2 week turnarounds. If it's monthly, then you need to look at the systems being employed and where are your blockages that are slowing down or reducing your efficiency. The other area we find is when there's handoffs between paper and digital, or when things have to be redigitized, and where there's too many systems employed that are not interoperable. So I would look at the end-to-end workflow that is there, and the data flows, and look for areas of improvement. And then, the way that we've managed to gain significant efficiencies in the past is to try to gamify with the team on how you improve things. So everyone gets involved, and you have a scoreboard essentially of what was the last best run you did, and what's the record you're trying to break. And again, we typically internally were even having essentially what was our best lap, what was our PB of last week, or last month, what's the PB we want to set, where can we do that? And look, granted, you can't always get the entire team to be involved, because you've got business as usual. You need to deliver results, you need to deliver designs. So in that case, what we recommend is setting up a sideline team where you can test this, and you create a safety net around that team to trial things, to try to evolve and break the existing systems to come up with a better approach. And then once they've proven that, then you can bring that in mainstream as a business process you're using in your broader team. And again, we've done that. We've seen that done. We've done it quite a bit internally, and that works really well.
Fantastic, Paul. Well, I want to thank you for presenting a wonderful webinar this afternoon, and thank you everyone for joining. The recording will be available on FBA's website within 24 hours. If you have any questions or comments regarding today's webinar, please feel free to email membership@fiberbroadband.org. FBA's next webinar is scheduled for Tuesday, June 11th at 2 p.m. Eastern, and the topic is Speed to Revenue. What can machine learning and artificial intelligence where can machine learning and artificial intelligence take network engineering and construction services? We look forward to seeing everyone in Orlando next week at Fiber Connect, and thank you again for joining today's FBA webinar.